Hi, today we are talking about Lesson 55, prime and composite numbers. I love looking at numbers and seeing how they relate to one another. Prime and composite numbers are ones that you will use a lot, and it's good to know. Our first thing we have to talk about are some vocabulary. First off, the word that I'm starting off with is the word divisible. It's right here. You have heard indivisible. We say it in the Pledge of Allegiance. One nation under God, indivisible with liberty and justice for all. Indivisible means not dividable. But dividable means, divisible, means that we are able to be divided by a whole number without a remainder. Oops. We'll erase that and we'll turn on our pen again. Come back to this. So without a remainder. So it's perfectly divided into perfect little even groups. When we're doing all those perfectly little groups, we can show all of that using something known as an array. And a rectangular arrangement of numbers or symbols in columns and rows. And rows. I'm going to move this over here, and I'm going to say rows. Our next thing is this special word, prime numbers. Let's talk about prime. Let's see. P-R-I-M-E. Prime numbers. Counting numbers that have exactly two and only two different factors. Let's go over here. Only two factors. You will find that when we look at numbers, for instance, let's see, when we look at numbers such as 9, we know that it has factors such as 1 and 9. We can say 1 times 9 is 9, or we can say 3 and times 3 is 9. So there are 3 factors to the number 9. However, let's look at 9's, add 10 more to 9, and we look at 19. If you were to go on to your math facts, you can review the number 19 never shows up on your math facts chart. That is because 19 is what we refer to as being a prime number. The only factors that make 19, if we multiply two numbers together to get the number 19, the only whole numbers that we can multiply together are 1 and 19. That is the example of a prime number. Now, there are a number of prime numbers. 2 is a prime number because we can only multiply 2 and 1 together to get 2. 5 is a prime number. 7 is a prime number. 11 is a prime number. You get where I'm going here. 2 is actually the only even number that is prime, incidentally. The rest are going to be odd. But just because a number is odd does not mean that it's always prime. So you have to really know your math facts to know which direction, know if a number is prime or not. Which comes to our next example. Composite numbers. This is our next vocabulary. Composite numbers are numbers with more than 2 factors. So these are numbers that are not prime. Just as 9 has 3 factors, 9 is a composite number. 19, though, is a prime number. So let's mess around with some of the vocabulary. We need to talk also about when something is a multiple of something. When we multiply in the 4s, we start off, if we multiply 4 by the numbers 1, 2, 3, 4, 5, we get 4, 8, 12, 16, 20, and 24, and we could keep going. These are all, we call them multiples of 4, meaning a whole number multiplied by 4 gets this product. And so multiples of 4 are what our products, the products when we multiply 4 by a number. What is the 4th multiple of 6? We look, and at this point, it's handy sometimes to consult your multiplication table. And so I look at my 4s, and here's my 4s times tables. And here, my first multiple is, let's see, we want the 4th multiple of 6. I look at my 6 times tables. I go 6 times 1 is 6, 6 times 2, that's my second multiple. My third multiple is 6 times 8. My 4th multiple is 6 times 4. And our answer for this is 24. Now back to my notes. What would the 3rd multiple of 8 be? We have to think about this. 3rd multiple of 8. So we look at our 8s, look on our number chart or our multiplication chart, and we say 8 times 3 is also 24. Let's see, here I am. Now 12 is a multiple of which whole numbers? I love thinking about this. There are a number of things that we can do. So we look, 12 is a multiple of which whole numbers? In this situation, they could be 2, 6, 3, or 4. And then list the 4 factors of 6. So we need to think about we know that to get the number 6, we go, these are the factors on this side, these are the multiples, and so we can say 1 times 6 equals 6. We can say 2 times 3 equals 6. So we have 1, 2, 3, 4 factors, and that tells us our factors are 1, 6, 2, and 3. And finally, list the factors of 7. You and I have talked about how 7 is a prime number. Because it is a prime number, the only factors that 7 has are itself multiplied by 1. And so the factors of 7 are 7 and 1. Finally, we've got to look at determining which numbers of these are prime. Let's look at 8. I know that 2 times 4 is 8. So do we have, are there other factors that can create 8? Yes, more than 2. In fact, we have 2 times 4 and 1 times 8. Let's look at 9. We've already talked about 9, but we know that the factors of 9 are 1 and 9 and 3. Because we know that 1 times 9 is 9, and 3 times 3 is 9. Here's 10. Let's look at what our factors are for 10. We can say 2 times 5. We can also say 10 times 1. So does this have more than 2 factors? Yes, because our factors are 2, 5, well, we'll go 1, 2, 5, and 10. Finally, 11. Looking at 11, can we divide it by, can we divide it by 2 and have a whole number? No. Can it be anything? Can we use any other factors to create 11 that are whole numbers? The answer to this is no. 11 is our prime number, and so the factor for 11 is 1 and 11. So you know that it's a factor when it's the only 2 numbers are, you know it's a prime number when the only 2 numbers are that are factors are itself and 1. And there you have it. We will do, we will do some lesson practice on page 355. I'll see you there.